Hello everyone! In this video, we'll be going over exponent rules and quadratic functions for algebra review for Physics 1010. We'll start with the three main exponent rules. If we have a number a raised to the m power, and we multiply that by the same number raised to the n power, how can we simplify this? Well, our exponent rules say that we keep the same base, and when we're multiplying these numbers, we need to take the sum, or the addition, of the powers. When we divide these numbers, a to the m over a to the n, we keep the same base, and we need to take the difference of these powers, the numerator minus the denominator. Lastly, if we have a number, a to the m, and we raise it to the nth power, then we need to take the product of these powers. So, our first example asks us to simplify 6 to the 7th power times 6 to the negative 3rd power. Well, we're multiplying these numbers, so we keep the base, we take the sum of these powers, making sure to keep negatives. This should give us 6 to the 4th power. Alternatively, negative 3 as a power implies that we can rewrite this as 6 to the 7th over 6 to the positive 3. This is what the negative means, where we can now take the difference of these powers, 6 to the 7th minus 3, and this should give us 6 to the 4th. Now, if we take 6 to the 7th and we raise it to the negative 3rd power, all we're doing is taking the product of these. 6 to the 7th times negative 3, and this should give us 6 to the negative 21st power. But with simplification, we may want to get rid of this negative exponent and rewrite this as 1 over 6 to the 21st power. That's about it for exponents. Next, we'll be taking a look at quadratic functions. These are in the form of ax squared plus bx plus c equals 0, where a, b, and c are coefficients or numbers, and x is our variable. For now, we'll assume that a is equal to 1. In order to solve for the zeros, or when x equals 0, let's make two sets of parentheses. We'll place x on the left of each with an addition sign, and we should have two numbers, d and e, and these will be equal to 0. Now, with the quadratic function, d times e should give us c, but d plus e should give us b. This may look like a substitution problem, but if you try to substitute for one variable, you'll just end up with ax squared plus bx plus c. So we'll need to do some guess and check here. Our first example, x squared plus 2x minus 3 equals 0. What are the zeros? Well, we'll make our parentheses, and we need to solve for these two numbers. D times e should give us c, and c is the coefficient without any variable, which is negative 3, and d plus e should give us 2. Now the factors of 3 are just 3 and 1, so we can have negative 3 and 1, or positive 3 and negative 1. Now, these two numbers need to add up to give us a positive 2. So we can only use these two. This means that x plus 3 times x minus 1 should equal 0. And from here, we know that if we have two parts or terms multiplied to give us 0, then both of them should equal 0. We can also check our work by foiling, or going backwards. FOIL means we need to multiply the first times the outer times the inner times the last. Our first is x times x. Then we need to add x times negative 1, then add 3 times x, then add 3 times negative 1. This should give us x squared minus x plus 3x minus 3, or x squared plus 2x minus 3, which checks our work. Lastly, let's take a look at quadratic equation. The quadratic equation says that if we don't know how to factor this, there's always the solution that x should equal negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. That's about it for this video. Thank you for watching.